Okay, the next section is 1.6. We're going to transform graphs today, functions. So we'll learn about transformations, both vertical and horizontal, reflections across the axis, stretches and shrinks, and we'll combine these transformations. And the why is because it'll help us to understand the relationships between the graphs and the similarities between parent functions and functions that we've transformed. Okay, so first, let's look at the different types of transformations. The book talks about rigid and non-rigid transformations. Rigid, obviously, are ones that leave the same shape, and non-rigid are like scale changes, where you actually like shrink or stretch a function so it doesn't have its same shape anymore. Okay, vertical and horizontal translations. If you subtract the number from x, it moves it to the right. If you add a number to x, it moves it to the left. And if you add outside of the function, it moves it up. And if you subtract outside of the function, it moves it down. I put those things on the formula sheet like this. So all the information you need is on the formula sheet right here, which you can use. The first few things are right. First few things I just went over are right here. All right. So next, then we can do an example of vertical translation to describe how this parent function, which is the absolute value, can be transformed to get this graph right here. Well, if we subtract 4 outside, it moves it down 1, 2, 3, 4. So the new function keeps everything the same except for it's shifted down 4 units. All right. Here's another example of finding equations for translations. Each view shows the graph of x cubed and a vertical or horizontal translation. So let's write equations for these real quick. So we want to write equations for the blue function. The red function is the original x cubed. This one's been shifted down 4, so we'd have y2 equals x cubed, and then it's been shifted down 3 units. The next one, y2, this one's been moved over 1, 2 to the left, so it'd be x plus 2 cubed. And the last one's been shifted over 1, 2, 3 to the right. 3 to the right would be x minus 3, and then we need to cube that. Okay, reflections. To reflect across the x-axis, just change the sign on y. If you reflect across the y-axis, change the sign on x. And that kind of makes sense if you just think about a point. If you reflect this point, x, y, over the x-axis, then it becomes x negative y. So you would change the sign on y to reflect over the x-axis, which is exactly what this says. All right, next is stretches and shrinks. If we divide x by a number, and if that number is bigger than 1, it's a stretch. If that number is less than 1, it's a shrink. And then vertical, if we multiply y by a number that's bigger than 1, it's a stretch. By a number that's less than 1, it's a shrink. And I put that on the formula sheet a little bit differently. That information's right here. I know it's a little different, but I say divide by y, and we'll go through examples where I explain how to access this information as well. All right, so here's an example. It says, let C1 be the curve defined by this equation. Find equations to the following non-rigid transformations. So we're going to do some stretches and shrinks here. First one, let C2 be the vertical stretch by a factor of 4. Now, a vertical stretch by a factor of 4, if we look at our formula sheet, vertical stretch means we divide y by a number bigger than 1. So what we're going to do is divide y over here by a number bigger than 1, which would be 4. Now, instead I'm going to multiply that by both sides. So I'll multiply that over here. So this would be the function that would give us the vertical stretch by a factor of 4. And then for b, the next function, c sub 3, is a horizontal shrink by a factor of 1/3. So horizontal shrinks, you divide x by a number between 0 and 1. So we're going to divide x by 1/3. So it's going to be x divided by 1/3. Divided by 1/3 is the same as multiplying by 3, though. So we can write that as 3x plus 3 cubed. Okay, you can always check these by graphing them as well to make sure that they look the way that you think they would. And I actually added an extra 3 there. Sorry about that. This is the equation. I have no idea why I add that extra 3 there. This would be, dividing x by a factor of 1/3. which is the same as multiplying by 3. That takes care of the horizontal shrink. And then this stays the same. All right, to try another example, here's y equals x squared. We want it to undergo the following transformations. So we want it to be horizontally shifted 5 units to the left, so that'd be x plus 5. And then we want a vertical stretch by a factor of 3. That's the same as dividing y by 3 on our formula sheet. Divide y by a number bigger than 1, vertical stretch. So I'm going to move that over here though, multiply both sides by 3. And then we need it translated 4 units up. So there's our new function, and it would look differently. It's 5 units to the left, it's vertically stretched, and 4 units up. So it would look thinner and way over here. All right, let's just try one more then. It says describe how to transform this graph right here. So we have this graph, which is our function, which we call it f. And then we're going to do some things to it. So first we're going to reflect it. All right, now on the formula sheet I said graphing a translated pair function, remember to do scale changes and reflections first. So let's do that reflection first. It's reflected over, we're changing the sign on y, and if we change the sign on y, it's reflected over the x-axis. This point goes here, this point goes 1, 2, 3, 4, so 1, 2, 3, 4. This is 1, 2, 3, so 1, 2, 3. So the function goes like this now. And then we need to move it, so I'll do it in red now. We need to move it 2 units to the right. So it'll be 1, 2, 1, 2, 1, 2, 1, 2. And then it'd look like this. Then we need to move it 4 units up. So I'll do that last one in green. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And 4. There we go. So the last one is the green one. So we would just say, simply that. We reflected over, just follow each of these steps. We reflected over the x-axis, shifted it to the right 2 units, and shifted it up 4 units. All right, let's try some homework problems and see if we can figure this out.